Welcome back. Today we will continue our work on Blackjack using Python. Now the first thing I want to do is I want to start in fact using a random reshuffle function in the main.py file, because at the moment what we do is we have a card class, so we know what a card is in terms of rank, in terms of suit, and most importantly we understand the value of a card. Of course there is still the issue with an ace, because an ace can be an 11, but it can also be a 1, which we have to determine later in the game. So the next step is we have a deck of 52 cards, but now we have to reshuffle it randomly. So what I have done here is I import the random library into main.py, and now I reshuffle our deck. Let's do that. I just make a comment here, reshuffle deck. So I refer to random and then it's simply reshuffle. Of course, you know, these commands, you can always look them up online. It's quite easy to find. There's lots of documentation. Of course, if you do these things many times, you get used to it. So here we have already a deck instance, which is simply deck, and then we refer to our cards. So that should do it. Again, to check whether we are successful, it might be useful to print it out. Let's do that. Again, deck.cards. So we can compare our initial print with the one after a reshuffle. Let's save it and go back to our Blackjack Live folder and run this as a main. Oops. Did I do any misspelling here? Reshuffle deck.cards. Oh yes, sorry. It's not reshuffle. This is what you think. It's actually just shuffle. That's a bit silly. Here we are. Let's do it. Yep, it does work actually, which is fantastic. So we have our initial order starting from the 2 of clubs, going all the way up to the ace of spades, and then once we reshuffle it starts differently. So it's of course random, which means if we run this again, because we don't have a random seed fixed, it would hopefully look different, and you see it does. It's now a 6 of clubs, so that's different from obviously the ace of clubs and so on. So every time we run this again, we have a different selection of cards, so the order is changing, which is exactly what we want. So now we are at a stage where we have a deck created, 52 cards in it. We can reshuffle the cards, change the order, and now we could actually start giving cards to players. So that's actually quite good. However, it would be really useful, before we go any further, to go back to our class deck and the card class, and think more strategically about testing these classes. At the moment, to test what we have implemented, we just import into main.py and then we actually run some tests. So actually what we have done before is we basically tested functionality here. However, that is not really the best way of doing it, because we already know that there are lots of interdependencies between different classes. So we know that our deck class actually uses the card class. So if I make a change to my card class, it might have a knock-on effect on my deck class. If I do the tests I have done here, I might not be able to isolate mistakes. So the main objective when you develop some more complicated programs is to try to isolate different parts of it. Yeah, so what we do is we build many different things, but small, and we keep testing them So we know if something goes wrong, hopefully we know we can trace it back to the original mistake. So what we now basically need is we need to introduce some tests. Now there are many different ways of doing this, but the way I quite like to do it is to start a new folder which we simply call tests. Okay. Now in this folder we put in a new file, and we can leave it empty. We save this file as dunder init.py. We know the dunder init function. It's one of the magic functions in Python, and we know what it does. So once you have you create an instance of a class, this dunder init function would run and would initialize it. So it automatically it runs. This is basically what it does. So it's a bit similar here. So once you touch the folder, it would basically run. And what it does, it tells Python that this folder is containing not one but maybe several Python scripts. So when you want to execute Python scripts from a folder, if you insert the dunder init.py, you could do it quite conveniently using the command line. And I will show you how to do this in a minute. So in here we don't have to actually put anything, but what I do is I want to type in what you need in the command prompt. So if you use, of course, Windows, it's CMD. Otherwise, it would be your terminal on a Mac OS. So here we basically can put in a comment on the command prompt. You would run all these tests as follows: as Python, then flag m, unit test, which we will use in a minute, discover, and then the name of a folder, which is tests. Yeah, so that should basically do it. Good. So now in here we create one more file, which we save as test for our cards.py. Let's do that. And we do another one which we call test underscore deck.py. So here we are. Good. So in here I'm gonna use a doc string. We can always add a few more comments. So here we might just, if we want to, we don't actually have to, but we can say, okay, this is simply, it tests the card class. And what we need to do this is we need to import unit test, which is a library that contains many very useful classes which we will have to rely on. Now in order to test the card class, we have to import this as well. So from card import card, that should do this. And now we specify a class for our tests. I call this conveniently the card test. Good. In here, and you might not have seen this before, we now specify that we rely on the test case class from the unit test library. So this is basically called an inheritance. So we inherit certain properties, which simply saves a lot of time. So we type in unit test, here we are, dot test case. So that is one class in the unit test library, so we don't have to replicate what is already there. The first test is usually a test for the different attributes. So in our cards we have two different attributes. We have a rank and a suit. So it might be useful to write tests for these. Again, it would be useful to test our technical representation of cards. And then finally, of course, we should check our value property. Yeah, so we should do that as well. Let's just specify this. Test has rank, referring to self. Okay, let's initialize a card, and I take as a card here the rank of, say, queen, and a suit which I think might be hearts. I should spell it correctly to be consistent. And now to test that the rank is correct, what we do is, after creating the card, we go into the attribute rank and we test, is it actually a queen. And it's quite convenient because now we can rely on the unit test library and we can use the assert equal function which is implemented. So if I do self assert equal, I go into card.rank and I check whether this actually refers to queen or not. Yeah. Let me do that, and now we do something very similar for our rank here. We just, for the suit, sorry, let's do suit. Test has suit, and we might maybe modify this just for the fun of it. Let's put a 10 here, and let's do clubs, and hopefully then if I ask for suit I should get clubs. Good, so that should be alright. Next we should test our technical representation. Test has technical representation, and again I initialize a card. Let me just change that a little bit. Let's call this a 7, and we do spades, and I now go into the representation of it. Let's do that. Here we are, and let's then call that here hopefully the 7 of spades, so that should work. Okay, next I check for value, so def test has value, and it might be useful maybe to create a few cards. You can do as many as you want. Let's just maybe do maybe 2. You can also do a few more. Let's put a 6 maybe here, and we do clubs, and we have here a queen sitting and hearts. Okay, that's pretty nice. And then again we do the self assert equal on both. Let me just do that. And what we do is we go into card1.value, and it should give us, in this first case, a 6, and in the second case it should be a 10. Okay. Okay, so now this would be actually sufficient, but sometimes you might want to run this not using the command prompt. In particular, if you're working in an IDE like Spider, you might actually run this as a main file. Or put differently, if you use the command prompt and you would execute test cards directly, so you would type python test_cards.py, you should specify what to do in this particular case. So the following is not really needed if you follow the approach we take here. What I do is I basically check if this is run as the main script. So again, you see the magic functions, the dunder functions in action. So I basically checked, is it the main script? If this is the case, you use unit test .main. Oops, we don't need that. So that should in theory work. I might have made a few mistakes, as I always do. Let's go back into our Blackjack live folder, and now what we do is we basically go into the tests folder and execute all the scripts there. It might be convenient actually in here to simply take what we have done here and copy paste that, just because I'm really lazy. So we have Python, then flag m, unit test, discover tests. Let's see, does it work? Oh, it doesn't work. Yeah, of course not, because this has to be equal to. Yeah, that's easy to fix. Let's do it again, and it's fine. It's running. So we have 4 tests, and they all pass, which is great. So that's pretty good. Okay, good. So now we do the same for our deck as well. So we can just maybe also actually copy paste the whole thing here. Let's do that. We are quite lazy today. Actually, we can close this one. We test here our deck class. And of course, to do this, we should also import deck. So from deck import deck. That should be fine. Let's do a deck test class here. Again, we inherit from test case, so that is all fine. We keep the statement below just in case, and we close that. And let me check. So the first thing we do is we have our initial value, or the initial content of self.cards, which is basically empty, and we might maybe just check whether this is the case. Let's do that. So we start here and we say test has no cards at the beginning of it. So in here, let me initialize an instance, which is simply deck, and then assert equal, and this is deck dot cards, which should be equal to an empty list. That should be the case. Now the next thing we have to check is whether it actually adds the cards. So def test adding cards. So again, we initialize our deck as we have done before, so that's quite fine. And then once we have our deck, we use our deck instance and use the instance method here, which is add cards, and we pass in card. This is why we also have to import the card class. So the next thing is we have to now start asserting stuff. Now of course the issue is we know we get 52 cards, yeah, so that is an awful lot. So it's not really very meaningful to specify 52 separate tests. I don't think this is really needed. Let me just quickly run the main file again. So what we should get is before we shuffle, of course, is the 2 of clubs. That's the start. and it goes up to the ace of spades. Yeah, so this is what we should actually find in our case. So that should be the case. Good. So what we now need to do is we have to maybe select a few of these cards. I don't think otherwise it would be very smart to do this. Now, as we store here the actual card which we initialize, it is suitable to check whether the ranks in the suits actually work. Yeah, so we can do that. So let me create only a few test cards. Yeah, so are the cards in the right place, basically. Okay, so here we have rank. It's the 2. Let me just do that. And suit, in this case, that's the first card, which is clubs. And the last card, which I call card 2, would be a rank of ace, and it would be spades. Yeah. Good. Now what we can do is we go into the deck of cards, like here, and we go into the first element. So we index to 0, which should give me an object that should look like card 1. It won't be equal to card 1 because that's a different object. You have to be careful here. That is not really true, yeah, because card 1 doesn't really exist in our add cards method. However, card 1 has a rank of 2, and this card in the deck should also have a rank of 2 and should have a suit of clubs, and this is what we can test. Yeah, so what we do here is we go, should not remove the bracket, we can go into card1.rank, and we just add the following to deck.cards and then indexing 0.rank. So here you see the beauty of object-oriented programming. We can just go further and further into the separate objects. So that would be a first test, and then we can do a second one, and we can do it on the suit here. That should be fine. And we do the same now for the last card. That last card is of course indexing -1, or well, if we know how long this list is, how many items, we can also specify that, but we just use -1, it's much easier, and we just call this 2 and 2, so fingers crossed. Okay, let me just do that. So now we have done hopefully the adding cards test, and finally let's test the len function. Let's do that. Again, we initialize a deck, and then we add our cards. So that's the same what we have done here. We add our cards, and then of course we do self assert equal. So what to be assert equal? Len deck should be 52. Okay, so that might work, fingers crossed. That looks okay. Always make sure you save it. It's quite easy not to do it, and then it won't do what it's supposed to do. Note here that I go into a deck and not deck.cards. Of course, deck.cards is a list, and it would have the len function would work because it's a list, but we introduced the len function to the deck class as well, so that would give you the same number. Yeah, so that's a proper test for the implementation of our len function. Okay, now this is all done. Let's see, using the arrows, we can just go a bit back. Python flag m unit test discover tests, run this, and we have a failure here. Card needs a positional argument in add cards. Oops, okay. So add cards, and this is line 27. Okay, so that's not massively obvious. Let me just go back to that, just to make sure we don't overlook any little detail. So we have deck add cards, we refer to card. That should be okay, that looks okay. Otherwise, let me just quickly check the deck function. That is add cards, so that is add cards here. Oh yeah, I see. Haha. You see that? So this is, you know, it's so easy to make some really stupid mistake. And the thing is, it does not point to the first mistake. It might point to something actually else, yeah, because that's sometimes happening, because it's not really a complete statement. Because the first statement actually would be correct, you see, because I can do what I want. I can just assign stuff, you know, that might actually run. But the next one then, of course, falls apart. Okay, let me just try this again. So, of course, when you initialize your deck using the deck class, you have to have open close brackets. Now it works, yeah? So it's all 7 tests run, they all pass. Great. Okay. So you see, it's super easy to make tiny mistakes. And I maybe just illustrate what happens usually in practice. So quite often you don't have only 3 different files. You might have 40, 50 files, and you might just make a tiny mistake. Yeah, you might, for instance, all of a sudden decide, okay, let's change it to self.ranks. Okay, that happens. Yeah, and when you then start testing, let's see what happens here, and all of a sudden, of course, you get lots and lots of errors because you have knock-on effects on other tests. Yeah. The good thing about the testing procedure is you can check where things are going wrong. Yeah, so this is actually quite a good thing to do. So you have to then go through them and see what's going on. Yeah, and the first hint is here in your test cards, line 12, that card object has no attribute rank. This is already telling you basically what is going on here. And then, of course, you have in other tests similar problems. And it's so easy to make a mistake, or just by accident make some changes to one of these many different classes, and it might have some really significant effects on other classes which you might not even know about. Yeah. So if we run this now again, let me just clear the screen, and we run this all over again. It does pass, so that's all fine. Good. That's all for this session. I hope you enjoyed the testing part of it, which is actually quite important. See you next time.